Good evening, everyone. A very warm welcome to today's session. My name is Pranavis, and I am an AI software engineer trainee. Today's session is about a good and emerging technology that is on agentic AI. Before we begin, I would like to mention to take a screenshot of this channel for further updates from BCBUZZ. If you have any questions during this session, feel free to reach out to us at support@bcbus.io. And this is my GitHub profile and LinkedIn ID. If you have any queries, you can reach out through LinkedIn. Today's agenda of the session is what is generative AI? In this section, we are going to understand the foundation of AI generated contents. And the second one is what is RAG? That is retrieval augmented generation. How AI combines retrieval and generation for more accurate results. The third section covers agentic AI, the evolution of AI agents that can act autonomously. And the fourth section is the difference between traditional RAG and agentic RAG. We are going to compare both the advantages of each approach and differences in approaching the technology using these approaches. And the final one is tools to create agentic AI, both code-based and no-code tools like Langflow and LangGraph. Finally, hands-on on agentic AI using code and creation of agentic AI using no-code platforms like Langflow. These are the disclaimers. Please kindly go through. Generative AI. What exactly is generative AI? In simple terms, it's a subset of artificial intelligence that enables machines to create new content, whether it may be text, images, or code, or even some sort of uh, other file types like uh, SVG, bit emojis, and so on. These technology generates a content by learning from the existing data. Generative AI goes a step further by generating something entirely new. Think about it. When you ask a model like ChatGPT to write a story, it doesn't recognize patterns. It creates a narrative based on its training. That's the power of generative models. The core mechanism behind generative AI involves a prompt, which is the input given by the user. This is the basic workflow how a generative AI works. A user gives a query or a prompt. The AI that processes that prompts using large language models, which has been trained on vast amounts of data, nearly billions and trillions of data. These language models can be hosted in cloud or locally, but these are CPU intensive and computationally very large. Finally, the LLMs compute the prompt by using vector embeddings, and they convert the expected output. That is the generated content that may be either image, audio, or text. This technology is not just a novelty, it is transforming the industries from content creation and customer service to software development and healthcare. Generative AI is reshaping the way we work and interact with machines. Next slide is about RAG, that is retrieval augmented generation. RAG is one of the heated technique that bridges the gap between retrieval and generation. It allows AI system to access external information like documents, databases, or other structured data and use that information to generate more accurate and contextually relevant responses. First of all, LLMs are being trained on a vast range of data, but not very recent data. For example, it can be trained before 2025 May 21st, but today's data it cannot update in a fraction of second or in a very small time. Here where we use the retrieval augmented generation. This retrieval augmented generations use an external database or external APIs or documents that is being updated till date. If a user prompts something, it finds a relevant information from those external resources, and it gives the external resources in addition with the query that the user gave. Here is where generation is used. The generation then use the information from the vector databases that is being most recent and generate accurate and most informed responses in time. This helps AI give better answers, especially when it does not have the all facts in its own training data. This is the basic workflow of RAG. Let's take a closer look into this basic workflow. User query. The user submits a question or request. A prompt is something that defines the LLM how it should behave. Like you are an some and so expert. You are a so and so specialist and so on. You are just uh, providing additional information to the model to do not outbound from the present knowledge. These prompt along with the user query go into the vector database. What is a vector database is you or a user can uh, type any query in English, but the model or any computative technology cannot understand English. So the English is being represented in a vector form that the model understands, or in a mathematical form that the model can understand the user's needs and it could answer. That is a vector database. There are many vectorization techniques, sentence to vector, word to vector. There are many vectorization techniques. In the vector database search, the system retrieves relevant documents or data points from a vector database. Let it be any PDF or documents that that is very new or more recent in time. The retrieved information from the vector database is then fed into the LLM. The LLM generates a well-informed and accurate response. Actually, the data and the user query is being sent into the LLM. The LLM summarizes everything into a single shot and makes it verbally and syntactically structured and sends the response to the user as output. This method ensures that AI provide context-aware and factually correct outputs, making it deal for applications like customer support, legal research, and technical documentation. But what happens when a task becomes more complex, when the AI needs to plan, reason, and make decisions on its own? That's where agentic AI comes into place. Now let's move into agentic AI and recent innovation in the field of artificial intelligence. Agentic AI refers to artificial intelligence systems that can act autonomously, make decisions, and pursue goals over time. These systems behave like agents, meaning they can autonomously, they can plan, they can adapt, they can interact with the environment or users to complete complex tasks without needing constant human instructions. For example, if you are an HR of any company, you develop an chatbot related to your company by using a simple RAG technique so that the employees can easily ask their queries using the chatbot. For example, if they can know how many days they can take leaves in a year. These data are only available in PDFs. So you can easily integrate this using RAG and you could take the output. But what happens is, if you want to fetch how many leaves left for a particular employee in a company, here is where agentic AI, here is where tool-based augmentation plus retrieval augmentation generation is being used. Here also agentic AI does not come into place. Here we connect the RAG with HR management tool so that the from we get the records of the user from the HRM tool and policy from the documents by using RAG. Finally, the agentic AI comes into place where you can plan, make decisions, and interact with the environment to complete the complex tasks. So that, for example, for same example, like HR recruitment can be automated using agentic AI. Unlike traditional AI models, which are often limited to single queries or simple tasks, agentic AI is designed for multiple step reasoning and problem solving. Imagine an AI agent that can analyze a dataset, identify gaps in the data, plan the next steps, execute actions, and generate insights all on its own. This is the power of agentic AI. This is the basic workflow how an agentic AI or AI agent works. These are all memory is being provided by the LLM. Tools are interfaced by our frameworks, and goals are provided by reasoning capabilities of the LLM. Now, this agent first plans the task. That is, it evaluates the end goal and plans the task into multiple steps. Uh, and then it uses for this use the LLM uses the reasoning capabilities to list the goals to achieve the goals in a procedural manner. Next, tools are being integrated to achieve autonomy. Now, actions are being performed autonomously on various environments, and the final output is being provided. Differences, there are two different approaches in RAG. One is the traditional RAG and agentic RAG. Traditional RAG generates a response using the info that is very limited. Traditional RAG follows one shot process. It retrieves information and generates a response in a single pass. While this is efficient, it lacks autonomy and deeper reasoning. On the other hand, agentic RAG is much more autonomous and dynamic. It can plan actions, retry if needed, update its search dynamically, and even reflect on its own performance. For example, while traditional RAG might answer a question using a set of documents, agentic RAG could perform a multi-step task like analyzing a dataset, identifying gaps, and suggesting improvements all on its own. This makes agentic RAG far more versatile and powerful for real-world applications. Next is traditional RAG's basic workflow that we saw earlier. For example, the user queries a prompt like specialization is provided. For example, you are a specialist in so and so department. Is to make the LLM do not outbound or thinking. For example, if you are searching something related to zoology, if your LLM answers about history, it would have no relevance here. So you are outbounding the LLM's capabilities by concatenating your user query and prompt. Now, what happens is, after concatenation of user query and prompt, these go into the vector database and search for new data. For example, I have a Udemy course list, and a user is querying for uh, generative AI courses. Now I go into the Udemy course list and I get the most recent course, and I retrieve from the vector database. I retrieve the context and I send it into the LLM. LLM summarizes the context and the user query and makes it factually and grammatically proper and provides the response to the user. This is a basic workflow. Let us think there is two vector DBs. For example, a Udemy course list and a live course list. Earlier we had only one course list, so that the model do not the workflow did not have any ambiguity. But here we have two databases, where both list but different domains. This cannot be the model cannot identify the domain by its own. For that, we use an agent that integrates the Udemy course list and live course list into it, so that the query is being sent to the agent, and the agent classifies what kind of request is this, and it interacts with the corresponding DB, and then gets the context from the respective DB and send it to the LLM. Now here, LLM summarizes the context and the query and the prompt from the user and the system prompts from the developer, and now articulates into a generalized summary and checks for grammatical errors and provides the output. This is how agentic AI makes the resource resource wastage efficient and uh, articulates the information properly, so that there is no information irrelevant information leakage. Now, these are some of the no code and code tools for creating AI agents or agentic AI. First one is LangChain. LangChain has many applications. LangChain is primarily used for RAG applications. LangChain provides various tools to integrate in RAG applications. LangChain is a framework for building applications that connect tools, memory, and APIs. LangGraph is an extension of LangChain that allows agents to operate as graphs with memory and loops, great for complex workflows. Recently there is a recently not very recently earlier this year there was a talk like chain of thoughts. What happens is, the LLM itself is chaining the thoughts internally without any human intervention. This is being achieved by memory and loops, that is internally done by these LangGraph tools. Then the other one is Llama Index. Helps agent access external knowledge like docs, PDFs, databases efficiently using indexes. In RAG, we use vector databases. These Llama Index help to convert words into vector using indexes, so that you could store the representation of the knowledge, which is in English or any language, into computer understandable language. AutoGPT. AutoGPT is an open source tool that is an autonomous agent that can plan, execute, and update tasks towards a given goal. Crew AI enables collaboration between multiple agents with specialized roles and coordination. Crew AI is very hot nowadays because of its multi capable agents, multi vision agents, and vision type agents. Because vision agents are agents that work with image data type. So Crew AI provide various integration tools and analysis tools to integrate images and analyze the insights using agents. Finally, let's move into some hands-on code. This code explains how to create agents, AI agents using a tool named Agno. First of all, for this I have used group API key. Group, you can get the API through group.com. You could apply this, could apply for a developer API and get the API keys from group.com. Agno is also one of the open source agentic AI tools that is used in market. These are the dependencies that you have to install. To create an agent, we have to import the agent from agno.agent. Agno is the tool and agent is the method name in the package. And I use the group model. So I have imported the corresponding package, and Y Finance Tools is one of the famous package that is used in analysis of analysis in equity market. The reasoning agent I have created is to compare the equity shares between uh, two companies. For this, I have used the Grook Llama 3.370B versatile model. You could also use 8B instant model for faster responses. Now I have this model I have selected, and the tools I have used is Y Finance Tools. Here I need the stock price and analyst recommendations, company info and company news. And the prompt that I give from my side is use tables to show data. That is, do not show uh, the in the findings in just text, summarize into table. That's what I'm instructing the model to summarize the insights into a table. Here I have given show to tool calls true because for educative purpose, uh, this is not recommendable to show the tool calls. And reasoning markdown true and reasoning true so that the agent can plan its flow according to the goal. This is the prompt. This is the user query. Write a report comparing Nvidia to Tesla. These are the calls. Tool calls. First is company, to get the company info of Nvidia, company info of Tesla, get current stock price of Nvidia, get current stock price of Tesla. This is the overall plan, and the final the response, which is the execution of the model. Company information. We first need, as per the tool calling it, the execution is being performed. Firstly, both comparison report has been generated. The stock price and the market capital of both companies are being compared here. Financial performance of both companies uh, on the last financial year, and 200-day average and 50-day average are being compared here. And the analyst recommendations are take from the internet and also from expert opinion in this, in the platform named Y Finance, are also being taken as a parameter to provide the end outcome. Valuation metrics. Finally, these are the valuation metrics that are being standardized to evaluate a company, and this is the conclusion. The conclusion says Nvidia has a strong track record of financial performance with high EPS and PE ratio and revenue growth. Tesla, on the other hand, has a higher current stock price and market capital, but its finance performance is less impressive. So overall, Nvidia appears to be attractive investment opportunity based on its financial performance and analyst recommendations. Nextly, we can see how to create AI agents using no-code platforms. For this, I am using a tool named LangGraph, LangFlow. LangFlow is also an open source tool which is used to create no-code agents. Here we can deploy agents using various components, so that you can create new flows here. Either you can create uh, the flows from scratch by selecting this basic prompting. For RAG based application, you can select vector store RAG, and agentic application use the simple agent, so that there are some predefined templates. You do not create everything from scratch. So I have created a basic prompting agent here. Here are the different components that you can use for your model. These are all just drag and drop functionality based components. You could just make it functional you just by connecting to other communicating component to use its functionality. So these are the components, and you can select various models that are present. I have used Grok here since it is open source. I have used Grok. This is a simple basic prompting model to answer questions only regarding generative AI. This is a input component. This prompt component is for, as I mentioned, not to outbound the model, and this is a agent, and I can select the different. You can select different type of agents from this drop down menu. You can select the model in the that is provided by your LLM. Here you have to provide the API key of the model, and you have this input is linked into the receiving input, and prompt is for agent instructions, and the response is being mapped to the chat output. Now let's see how the basic agent works here. Select the proper model because all models do not work in the interface APIs. They work in local playgrounds of Grok, but interface API provide limited access to their models. Since I get a error here, this is how the agent is working. So this by following these methodologies, you can implement a agent in no code using Langflow. Thank you for joining me today. I hope this session has provided valuable insights into generative AI, RAG, and agentic AI. If you have any questions, feel free to reach out more at support@bcbuzz.io.